In this module, you will learn how to calculate heights and distances using trigonometric ratios. In everyday life, we come across many buildings, monuments, and other structures. The heights of these structures can be found using trigonometric ratios. Let's review some basic terminology associated with finding heights and distances. Suppose an observer is looking at the top of a tower. The line joining that object and the eye of the observer is called the line of sight. The angle between the horizontal line and the line of sight, which is above the observer's eye, is called the angle of elevation. Suppose the observer is standing on the edge of a cliff and observing a boat on the water. The line of sight will be as shown. Here, the angle between the horizontal line and line of sight, which is below the observer's eye, is called the angle of depression. Let's see some examples on how angles of elevation and depression can be used to find the heights of the objects. A pole of height 25 meters stands vertically on the ground. The angle of elevation of the top of the pole from an observation point on the ground is 45 degrees. We have to find the distance of the point from the pole. Let Mn represent the pole and the point from where the top of the pole is observed be P. The angle of elevation from point P to the top of the pole is 45 degrees. We need to find the distance of the point P from the foot of the pole M. Here, triangle NMP is a right-angled triangle. In the triangle, tan 45 degrees is equal to Mn divided by MP. Let's substitute the value of Mn. Mn is equal to 25 meters. The value of tan 45 degrees is equal to 1. Rearranging, we get the value of MP, that is, the distance of the foot of the pole from the point, is equal to 25 meters. Let's look at another example. A boy standing on a tower observes a ball on the ground at an angle of depression of 30 degrees. The ball is located 60 meters from the foot of the tower. Let's find the height of the tower using the angle of depression. Let AB represent the tower. The ball is located 60 meters away from the foot of the tower. The boy observes the ball at an angle of depression of 30 degrees. When this line is joined, a triangle is formed. Here, the side AC makes an angle of 30 degrees with the horizontal AP. Considering the side AC as the transversal of parallel lines AP and BC, angle ACB and angle PAC form a pair of alternate angles. Hence, they are equal. Therefore, angle ACB is equal to 30 degrees. In the triangle ABC, tan 30 degrees is equal to AB divided by BC. Substituting the values, tan 30 is equal to 1 by root 3 and BC equal to 60 meters. We get AB by 60 equal to 1 by square root of 3. Rearranging the expression, we get AB equal to 60 by square root of 3. On simplifying, we get 20 multiplied by square root of 3 meters, which is the height of the tower. In this module, you learnt that the line joining the observer's eye and the object observed is called line of sight. The angle between the horizontal line and the line of sight, which is above the observer's eye, is called the angle of elevation. The angle between the horizontal line and the line of sight, which is below the observer's eye, is called the angle of depression.